Okay, so we learned how to calculate the margin of error and the confidence interval, right? So we are going to apply the result to some examples, right? The first example I'm going to think about is, of course, it's fake numbers, fake data, but like we will think about insurance companies' estimation of the expected cost of COVID-19 treatment. Of course, again, the numbers are fake. Just I made up the numbers for simplicity. Okay, suppose that you are an data analyst in a insurance company. You would like to estimate how much the COVID treatment would cost, right? So you observe 100 patients, and you get data like the data from the 100 observations give you these numbers. The average cost was $20,000 per patient, and the standard deviation was $5,000, right? And okay, so this is just data. What we want is the insurance company wants a 99% confidence interval, right? So these numbers are random. So if you had a different 100 patients, you may get different numbers. So we'd like to make a confidence interval that covers 99% of the possibility. Okay, simply the answer is pretty simple. Just calculate four numbers, plug them into this formula, right? So it's even easier because I already gave you x bar is 20,000, standard deviation is 5,000, sample size is 100. So square root of that is 10. So you already cleared three numbers, right? Then what? The only remaining number is this part, z value, from the standard normal distribution. And remember, we used 99% confidence level, which means you allow 1% error probability. That means you need to find from the standard normal distribution, you need to find top 0.5% value, because upside probability is 0.5%. Among 1% error probability, only 0.5%, half percent is on the right side. So you need to find this value that has a cumulative probability of 99.5%. Okay? And then using this table, you may just take this number using this table. So 2.58. You may use Excel, still you'll get the same number. So approximate number is 2.58. Then it is too easy. Just enter this number here and you get the other numbers. So, just this is how you calculate the margin of error. Margin of error is $1,290, right? So you have to allow plus minus this much around the sample average, 20,000. So sample average was 20,000, which is a point estimator, but the truth could be slightly greater or smaller than this. How much? This much, right? So $1,290 should be subtracted and added. Then that's the interval. So the confidence interval looks like this. So the expected the population mean of COVID-19 treatment would be somewhere in between $18,710, but below $21,290, right? So it will be somewhere between them, and the accuracy is 99%. Confidence level is 99%, right? That is how we utilize the interval estimator. Okay, then I will have you do this again with a different confidence level. Now assume 90% confidence level and recalculate the margin of error and confidence interval, right? Do it by yourself. Pause the video here and do the math. It's pretty simple. Okay, let me give you the answer. So, we are going to use this formula. And everything is the same. The data are the same, but the only difference is alpha. We change it 99% confidence level to 90%. So this is the only difference. We need to find this probability, right? Right? So, and you may just use this table, this number. 90% will give you, for 90% you need to use 1.64. That is plugged in here in the place of lowercase z. And then it is easy. It is 1.64 standard deviation and sample size. Calculate that. You get another margin of error. The new margin of error is now smaller, only $820. So, as before, you subtract and add that much around the sample average. Sample average is 20,000, and if you subtract the margin of error, you get this lower limit. If you add the margin of error, you get upper limit. So these two numbers make a interval. That is the confidence interval for 90%. Okay. These are the results. So if you calculate 95% confidence level, then you are going to get another interval. So what I wanted to show you here is, as you increase the confidence level, as you see, so first the margin of error was greater than 1000, but like when you lower the confidence level, it became 800. So that means higher confidence level requires larger margin of error, so your confidence interval will be wider. That is natural. This is the underlying trade-off that I have been talking about, like for confidence interval. So as you see, the lower confidence limit goes down as you increase confidence level, and upper confidence limit increases as you increase confidence level, right? And also you observe that the only difference is this part. You just need to change this part when you change the confidence level. This part, the standard error does not change. It depends only on the data. Your choice does not affect this part, right? So for these three confidence levels, the center is always 20,000. Center does not change either, right? So, it's pretty simple. Based on the simple formula, you can check all the theories again, confirm the trade-off and the formula. Okay, then I will show you another direction here. Okay, I just said a trade-off between them. Is there any way, for example, your insurance company wants to do a better job? So the estimator, the result is not that satisfactory, for example. You want a higher confidence interval with smaller margin of error. How can you do that? There is only one possible way you can do that. Collect more data. Include more data, like obtain more data and increase the sample size. Then you can make your estimator better, like more accurate. So you can achieve, both goals. That's simple idea. In many cases, it's not easy to do, but if possible, that would be great. So we will think about this idea. Okay, so your insurance company, your boss, ask you to command you do this. Say, give me a confidence interval with 99% confidence level, but your margin of error should be at most $500. So make the margin of error at $500 without sacrificing confidence level. Then, how much sample size do you need? That is another question. Interesting question, right? You have specific target of margin of error and confidence level. Then you design the survey. You design the experiment. So in statistics, this is another field like a survey design or experiment design. So how much you need before collecting the data, you have to set the target sample size. How can we do that? So first, think about this. Additional constraint we have is on the margin of error. Your margin of error must be at most $500. This is requirement. Okay? So at the same time, your alpha, the error probability, should be 1%. So confidence level should be 99%. So you have two constraints, this inequality, and alpha is fixed. Then here, like standard deviation is nothing you can change. So another thing you can change, so the only thing you can change here is n, sample size, right? So we are going to solve this inequality to get the sample size you need, right? Let me show you. So 99% is the confidence level fixed. So this number, again, going back to the table, excuse me. So we know 99% confidence level implies 2.58. That is, where did we go? So you need to use 2.58 here, right? It's a common number, and standard deviation is 5,000. It's already known, like estimated. You cannot change the standard error in COVID treatment. Then this is the only unknown in this inequality. Like in this inequality, how can you do this? So we write this way, and like multiply square root n, divide by 500 on both sides. Then you can rearrange these two terms. So square root of n must be greater than or equal to this number. And you can calculate this number. And to remove the square root here, radical, so we are going to take square on both sides. Then you can remove this radical. Then you get this inequality. So changing the right and left. N, the sample size, must be greater than or equal to something squared. Calculate that. You are going to get this number, 665 something. And because the sample size should be a natural number, the minimum required sample size should be 666, right? That is the smallest integer that satisfies this inequality. Okay? So then you can say that, okay, you can say to your boss that, okay, I can do that. I can make the margin of error smaller than 500 and confidence level is 99% if you give me more data so that the sample size becomes 666. That is how you design an experiment. Okay, sampling design. Then I will ask you even a harder task. Okay, that was not that satisfactory. I'd like to reduce the margin of error even smaller than $300. Then, how much sample size would you need? Do it by yourself. Calculate the number. You will need a calculator. So using a calculator is always okay to me. Try this. Okay, I'll show you the how to do it. So the only difference is this part. Earlier, I needed to make it 500, but now you need to do it 300, right? 300, so 500 should be 300 now. So 300, 300. New inequality, 300, 300. And calculate that side and take square. Then you are going to get the sample size must be greater than or equal to 43 squared, which is like 1800, more than 1800. So this is the required sample size, right? And it is intuitive. So ideally, you want to minimize the margin of error. So to reduce the margin of error, that means you have to reduce the error, right? Margin of error is for errors. So you have to make smaller errors. That means to make errors smaller, you need more information, larger sample size, which is very natural. So we can find it in our example. Okay, that was the first example for confidence interval. The second example is a more common example, like election prediction. So in the next video, I will show you how this result was generated. How political research institutes design their survey, how they calculate their margin of error and predictions. Okay, see you later.